In this class, we will discuss the limitations of Coulomb's law. So, what are the limitations? Limitations means when Coulomb's law is obeys, when it is possible. Two limitations are there. First limitation is we can take only point charges. It is possible only point charges. Means it is a small charges. And second one is always one charge is rest and one more charge is motion. One more charge is motion. So these are the very important limitations in Coulomb's law calculation. Second concept is principle of superposition. Superposition means if we can take a system, so this is one system. So in this system, three charges are present. So this is Q1 and one more charge is Q2, one more charge is Q3. So here in this system, three charges are present. We have to calculate the force. We have to calculate the force on charge 3. Force on charge 3. Force on charge 3 means F on 3. F on 3. Three charges will be in positive charges. F on 3 it is equal to 2. So this for a charge Q1 is a repulse Q3. Means it is Q31 plus one more charge is this second charge also repulse force between Q3 means Q32. Adding of all the forces. Adding of all the forces except on this charge. Except on this charge, it is equal to force. That is superposition principle in calculation of the force in a system. So if you can take a system, n number of charges are there. Means n number of charges are there in a system. At nth number we have to calculate the force. At nth number we have to calculate the force means adding of all the forces except adding of all the forces and sum, it is equal to the net force on that charge. This is the easiest like adding of all the charges, adding of all the forces in a system. This is the superposition principle. We have to discuss some applications. First application is in pendulum application related. This is one charge hanging like this. One charge is placed on the earth surface. This is for example Q1 charge. This is Q2 charge. Q1 charge having mass is M1 and Q2 charge is mass M2. So in between two charges distance is capital small h. Small h. So here Q1. So what are the forces are acting on the Q1? First force is always we know that is in mg. Mg, it is acting towards the center of the mass uh, to gravity, to gravity, gravitational force. Next force is acting against the gravitational force, that is in tension force. Next one more force is Q2 is always repulse this Q1 because both will be in same sign of charges. That is forces Fc. We have to calculate the equilibrium condition. Equilibrium condition, what are the net force? at equilibrium condition, Fc plus T, both will be in same direction. So adding up those two forces, it is equal to M1G. That is equal to M1G. If tension force will be 0, then Fc equal to M1G. Fc means it is a Coulomb force. Coulomb force means it is K into first charge is Q1, second charge is Q2. Distance between two charges are h square. It is equal to M1G. This is one application. Next, the second application is some inclination. This is one inclination of the body. This is the angle theta. Here I am placed one charge that is fixed. That is the charge is having mass is m1. So here it is unfold on that body m2, m2. So this is the body m1 having charge is q1, m2 is having charge q2, q2. So m1 is fixed. M1 is fixed. M1 is fixed. So we know first force is due to gravity. So center of the mass that is acting m2v. This is the mass m2. So now I can write m2v. So these force gravitational forces are like I can write two component of forces. One is sine component. One more is cos component. This is m2z m2z cos theta, and this is m2z sin theta. M2z sin theta. How I can write, because this is the theta is here, theta is there. So this theta is adjacent side is cos theta, opponent side is sin theta. So one more force is due to Q1, Q2 is repulse like this. That is the force, repulsive force Fc, and one normal force is acting normal to the surface. That is N. N. Here also we calculate the equilibrium condition. What are the net forces? Here Fc Coulomb force, it is equal and opposite direction, that is minus m2 g sin theta. It is in motion, second charge, so it is equal to m2 into a, means it is F equal to m into a, F equal to m into a. Now here, so for example, this is the smooth surface. Now I can then take in rough surface. One more force is acting, that is the friction force is against like this. So this is Fc. Friction force is acting like this. Both will be in same direction. Friction force and Coulomb's force. Now I can write like this. And minus m2g sin theta is equal to m2 into a. It is equal to m2 into a. Now you can write a frictional force, that is Fc equal to mu into N, or you can write Coulomb's force, that is Fc equal to K into Q1 Q2. Sorry, K equal to F. Now I can write like this: Fc equal to K into Q1 Q2. So in between two charges separated by distance, for example, this is I am taking, this is for example L R whatever. Now I am taking R. So here I am writing as R square. So in the substituting of the place of capital Fc, that is the Coulomb force, we can write like this, and in the place of friction we can write like this, mu n. So this is the one more application. Next we'll discuss one more application. Next application is like this. This is one square. So here, for example, in this corner, I placed a charge 2q. Here I placed a charge minus q. And here I placed a charge minus 3q. Here I placed a charge 4q. So at this corner, node is represented. For example, it is in 1, this is node 2, this is node 3, this is node 4. But I need to calculate the net force on charge Q, capital Q. What are the net force at capital Q? So what are the net force at capital Q? We have to calculate. So how I can calculate this one? So we know very well. So for example, if you can take node 1, this is 2q, it is in positive charge, capital Q is also positive charge. These charges repulse this one, means this is the force. So force is 2F. Why I will get the 2F? Because charge 2q into q. So I will get the 2F. Now here, this is the second charge. Second charge is negative and this is positive. These positive charges towards towards this is F. This is F. And third node is 4q. This is q. So these charges repulse like this direction. This is 4f. This is 4f. So and this is minus 3q, negative charge. This is positive charge, attacks towards this is 3f. Now I need to calculate the net force. Means, for example, if I can take 1 and 3 nodes, 1 is 4f, 3 node towards 2f. In between difference is 4f minus 2f is and 2f. 2f is acting like this direction, upper force direction 2f. And next one is this is 3f, this is f. 3f minus f, 2f. 2f is acting like upper direction, upper force direction, that is 2f. So new vectors are 2f and 2f. In between this is net force. In between this is net force. So here this is the angle is 90. So net force equal under root of f1 square plus f2 square plus 2f1 f2 into cos 90. Here f1 is 2f and f2 is also 2f. f1 is 2f and f2 is also 2f. Then theta is 90. Theta is 90 degrees. Then net force will be root 8 into f. Root 8 into f. This is the net force at the charge q. Next, one more application is, so for example, here one charge is there, that is in capital Q. So in this charge, some of the portion I would like to remove. So for example, this is I remove from this charge. Removed portion is displaced by somewhere in d distance. So after removal of this will be like this, and removal part is displaced by small distance d. So here after removal, this q will become q minus q. Removal charge is small q. Removal charge is small q. So in between distance is d. So what are the relation between how much of charge is removed from capital Q? What is the possibility? Possibility is in between experienced force is maximum, df by dq. Maximum or minimum means it is equal to 0. Differentiation is equal to 0. Means we can take f equal k into q minus q into q upon distance is d square, it is equal to 0. Then I'm a differentiation and it is equal to 0. Finally I'm getting the value, that is small q, it is equal to capital Q upon 2. This much of charge is separated from original charge. Half of the charges is possible to remove from the main charge. Means a small charge q is separated from capital Q and kept at a certain distance d. What should be the value of q at the maximum forces experience? Maximum force experience condition. This much of charge is separated from capital Q.